Look at here. Here every statement talks about Arrhenius equation and you should find out which one is incorrect. High activation energy usually implies a fast reaction. So I will just take activation energy as energy barrier. When I will say that the activation energy is high, crossing this barrier is difficult. When something is difficult, the process takes place over there slowly. That means any reaction where the activation energy high, that indicates that the reaction what we are talking about, it will happen slowly. High activation usually implies a fast reaction. The statement given is wrong. We got wrong statement at option A itself. But still let's look at B, C and D. Rate constant increases with the increase in temperature. This is due to greater number of collisions whose energy exceeds that of activation energy. Absolutely correct. So always you remember the rate constant directly proportional to temperature. Let me tell you that for every 10 degree rise in temperature, rate constant of reaction doubles. Remember, 10 degrees Celsius, if you all make it 20 degrees Celsius, absolutely what happened, the rate of reaction, rate constant of reaction will doubles. Let me show you the Maxwell distribution curve. You might have seen this in NCERT book. The fraction of molecules you take along y-axis and energy factor you take it along x-axis, and you consider that this is a threshold energy. When temperature is low, you just show that the graph looks like this. Only this fraction of reactant molecule, they have energy of threshold. So only these many reactant molecules responsible for the effective collision and they responsible for the formation of product. Now what happened? You just increase temperature 10 degree more. Now exactly what graph you will get, that looks like this, where I am showing you people that now you look at the double the number of reactant molecules become active. It was only this much, now it will got doubled. Because it got doubled here, more molecules will give you now the effective collision, so the rate of reaction will get double here. So you are saying that as temperature increases, the number of effective collisions becomes more because the number of active molecules having threshold energy point becomes more. So that is what given, right? Rate constant increases with the increase in temperature. That is what I said. Due to greater number of collisions whose energy exceeds the activation energy, that is what we can see. Statement right, answer cannot be. C. Higher the magnitude of activation energy, stronger the temperature dependence of rate constant. Everybody knows that when you have more energy barrier, crossing barrier becomes difficult. Now you give more temperature so that more active molecules you will get. So reactions will take place now more effectively. So that is what they are saying. When the activation energy more, you have a temperature dependence becomes more. So yes, it's right statement. So it cannot be the right answer. The pre-exponential factor is a measure of the rate at which the collision occurs irrespective of their energy. Right. I know that K equal to AE to the power minus EA by RT is the Arrhenius equation. This is the exponential factor and this one is the pre-exponential factor. I will call it as Arrhenius factor or a frequency factor, and I know that it will just speak collision frequency. I know collision frequency is the number of collisions that's happening per unit volume per second. It won't talks about how many effective collisions. It simply talks about the reactant molecules colliding per unit volume in per second. It won't talk about whether these reactant molecules has threshold energy. No, it won't talk about. It tells that how many collisions are happening in this unit volume in a given second. So yes, it does not depend upon energy. Irrespective of energy, the pre-exponential factor, it only talks about the number of collisions that takes place. So even this is the right statement and cannot be the right answer. So the incorrect statement is given option A. So option A is my answer here.